Hello, everyone. My name is Jenny. I'm with ICF, and we're going to go ahead and get this webinar kicked off. So I just wanted to say a big thank you to everyone for joining today and taking time out of their day for this all-electric new home construction webinar. And thank you to DTE Energy and Consumers Energy. We have some pilots that we'll be discussing that they have launched or will be launching. And here is our agenda that we have today. We're going to run through some introductions, talk about electrification, touch on a few aspects of all electric homes, including the heat pump water heaters, ventilation, the HERS rating system. And then lastly, we'll touch on the pilots that we're launching and the builder incentives. And then we'll have some contact information in case you have any additional questions. And throughout the webinar, if you have any questions, there should be a panel up on your screen for you to drop any questions in, and we'll address all of those at the very end. Here we have our presenters. So we'll be kicking it off with Brett Little from GreenHome Institute, and passing it over to Mitsubishi, WaterFurnace International, Rheem, Panasonic, and ICF representatives.
Hey, thank you so much, Jennifer. My name is Brett Little. I'm the program manager here at the nonprofit, the GreenHome Institute, and I'm just going to briefly introduce you to the really overarching concept of electrification. This is actually a tip out of our 10 tips to building low carbon net zero homes. It's tip number 6, so it's a little bit of a hint. We're going to be talking about the full, all 10 of them next week at our net zero conference. Hopefully you can join us. But the whole idea is this movement and this shift towards electrification of almost everything that we do. So one question I have for everybody in a poll here is how many solar panels does it take to offset one gas water heater? So just real quick, if you want to take 5 seconds to take that poll. Five, four, three, two, one, and share it out here. We've got about 40% of you saying 3, 20% 5, 34% of you saying trick question. So great job to those of you who said trick question, right? The reality is that we can't offset combustion or undo it in any way with any kind of renewables or solar power. Other concerns out there, this is a faraway state, a situation that occurred where the wrong, gas was pushed down the line, and it created a huge issue right before Thanksgiving in 2018. Big concern we see with gas, carbon monoxide is something that comes from it, right? That's what comes from it. We see chimneys that are used to get rid of it can be leaking, which can cause water issues, pest issues, heat loss, all sorts of problems. And one thing is just efficiency in general. We top out at 98%. That's as far, we've done everything we can with our gas systems, but electric is climbing and climbing in efficiency. Now, our former president, Ronald Reagan, pushed this before he was president in partnership with GE. The idea was to live better electrically. Back in, I don't know, the late 70s and the 80s was a big push for this. You can get these medallions on eBay for these certified homes. Unfortunately, they were just way too far ahead of their time for their ideas, and the technology wasn't there yet. But we are seeing growth. Here is a chart just across the country. EIA, Energy Information Association, they update this all the time. You can see homes that are all electric just growing significantly, obviously in more parts of the country than up here, but they are growing. One thing we're seeing too is if you are building this way, it's one way to get ahead of potential coming codes, where we see cities across the country rethinking natural gas infrastructure. And so this is just another way to stay innovative in your construction projects. One question that we have here, another question that we have here is there heat outside in the wintertime? And don't think today, but just, in the cold winter. It is getting colder though. 5, 4, 3, 2, 1. So yeah, 93% of you said yes. So you all know this. You know that we can extract heat out of the air, out of the ground, even in the dead of winter, in the coldest of coldest climates. And a lot of our folks here coming after me are really going to talk about the technologies that can get us there. The biggest hurdle is in our kitchens. And we are seeing top chefs across the country taking a look at induction, right? If you love to cook, you hate electric. Electric's more efficient than gas. Induction's more efficient than both of them. And you can cook some great things on it. And so the biggest concern that we have with natural gas, use is the cooking. That people love it for that. So we see this happening. You can get these single top plates for your clients, have them check out induction, test it out. We see libraries in California renting them out to folks who want to try it and see if it works for them. To learn more, we've got something on our YouTube channel, a little bit old, but still relevant, the economics of electrifying buildings from our friends over at the Rocky Mountain Institute. You can check that session out. And our friends at RMI just keep the hits coming. They've got building electrification that helps Illinois achieve its climate goals. Illinois has very relevant issues, concerns, grid technology that Michigan has. So I think you can learn a lot about that. We have Luis Charo joining us next week during our conference to talk a little bit about that. And we've got, you can join the Electrify Everything Facebook group. And we've got a lot of great conversations and feedback from newbies all the way up to industry professionals sharing their ideas, new technologies, new things you can do, projects and all that. So you can join us online at Facebook. And with that, I'm excited to pass it off here to Greg. Sorry, looks like my slides got stuck there, but we'll keep moving forward nonetheless. So Greg, take it away.
Thank you, Brett. So my name is Greg Driscoll, and I'm a regional manager with Mitsubishi Electric. And our focus today is really going to be on this cold climate air source heat pump. Cold climate heat pumps, as Brett mentioned, we have a lot of additional heat outside in the air. And so even that cold air can contain that heat, but there are some things that we have to do for cold climate heat pumps. And that requires some advanced technology. And that's where the cold climate manufacturers come into this, and Mitsubishi. So Mitsubishi utilizes an inverter compressor and a flash injection circuit to get some additional heat that isn't in that outside air. This helps to provide more comfortable indoor temperatures. And these systems can operate all the way down to minus 13 degrees while getting somewhere around 76% of the heating capacity out of that unit. So these compressors ramp up and down based upon the needs of each indoor unit that is tied to it. It's kind of similar to cruise control. So think about cruise control on your car, how that operates when you put it in cruise control. And when you get to that optimum speed, the RPMs ramp back down. And that's where we get this additional energy savings from. And it can be up to 40% more efficient than your conventional heating and cooling systems out there. Now, also, because we filter from the space, these indoor units offer that additional filters that can capture those allergens and other contaminants in the air. Our units are also very quiet, and all of the competitors are in that very similar range. But for example, an indoor unit of ours, high wall, can operate down to 19 decibels, 19 decibels. So think about that as a library is normally at a 30 decibel level. So quieter than a human whisper. And our outdoor units operate anywhere between from 58 decibels and below. So with that, what we're showing here is that Mitsubishi Electric can be designed to handle those homes and those uncomfortable rooms in your entire house. And we can handle this equipment very well in terms of renovations, new constructions, add-ons. These systems are becoming very prevalent out in the industry today. Because our systems focus on those individual living spaces, they treat every room in different manners, making it more customizable for your homeowner to save that additional energy. So if we used a cold climate, what we call a multi-zone system, where we have multiple indoor heads tied to an outdoor unit, they could have different temperatures in each zone. So Mitsubishi offers a wide array of different systems. We offer high wall systems. We offer floor mounted, ducted models that can tie to the outdoor units. And then we also offer many different types of controllers. In most cases, they will have a handheld remote, but then they can be upgraded for either a wall mounted model. You could use a third-party thermostat, or you could use a Wi-Fi type system and tie right directly to those different heads. Now, the reason we're talking about cold climate here is because with that Mitsubishi Hyperheat technology, what we're showing you here is the Metro Detroit area. And on average, over the course of the last number of years, the average temperature is only around 19 degrees in the Metro Detroit area. And so as we talked about that, our systems can do 100% heating capability at 5 degrees, and they can do somewhere around 76% capacity on average. Some are a little higher, some are slightly lower. But as you can see, we could do a very good job utilizing this cold climate heat pump for your heating sources in Michigan. Now, what we're showing, we'd like to show here is just an average cost of BTUs versus the different energies out there. So as you see here, propane on average, the cost per million BTUs. You also have your natural gas, which we all know natural gas is very cost effective right now. We do still have some homes in the Michigan area that utilize electric resistance heat. And so this is a great way to displace that electric heat as well in some of those homes by utilizing these cold climate heat pumps. Now, the last section here is we're just showing you what potentially a cold climate heat pump would cost in million BTUs. And we gave you the two different energy companies that are here in Michigan, the bigger ones. And so we're showing you that, but also you need to definitely look at when you install these systems about interruptible type service. And as you see on the far right-hand side, with that interruptible service for these systems, you can get a very good rate and be very cost effective versus natural gas. So again, when you compare these systems to all of the other systems out there, it's very cost effective. You can give the homeowner customization for their home, and it's a very viable option for the Michigan area. Now, what I'd like to do is hand this off to Alan Waller as our next presenter.
Thank you. Hi, I'm Alan Waller. I'm with Territory Manager for WaterFurnace International. We're based in Fort Wayne, Indiana, and we've been manufacturing geothermal heat pumps since 1983. This is something to talk about and where we're heading. We have a Volt electric car in the driveway, and we have the chimney over in the house. And then we're talking data here from the EIA, and basically showing amount of BTUs here in the Midwest on an average home, average million BTUs per home. They're using around 94,000 BTUs in the space to heat our homes. So they're showing the space heating, water heating, and air conditioning, and where that power and what our usage are per BTUs and million watts of hours there in kilowatt hours. So we're using a lot more BTUs than we are for our electric in the home. So about 25% of all electric needs are based on our washing machine, dryers, refrigerators, freezers, all your appliances, TVs, coffee machines. So all that electrical use is basically 25% of our in-home capacity. The rest of it is thermal, and that's 72 million BTUs of what we're using a year in our average Midwest home, or 21.3 million watts. So 75% of that is thermal energy that we're using. And if we can go to electric, where geothermal heat pumps take that 100% of electric, we produce 100% thermal output with 75% less input. So we add just a little bit more electric use, but we gain 55% renewable energy for the thermal part of the home. Where a gas furnace is only going to give you 78 to 80% efficiency, and the rest would be going up your chimney and producing carbon monoxide. Where a geothermal heat pump in any weather, any climate, is going to continue to present 300 to 600% efficiency. So it provides good renewable clean energy, helps improve the utility load factor, so it actually drops the peak load in the summer and helps fill the valley in the winter time. Definitely extreme efficiencies. It's cold climate resistance. Definitely has a long lifestyle because it's inside the home and it doesn't get weathered from the outdoors. And again, we can still heat your home in this type of weather, and this is what's coming our way, or here. And we can show the data that we've acquired here in the last few years with our Symphony Insight. And it's a Wi-Fi program connected to our unit, monitoring all aspects every 10 seconds of the unit operation. And here at this time, when we did this slide, we have a total of 4589 units out there installed. And right now we're over 7,200. But the average system in the US geothermal heat pump, with an average, I think, around 12 cents a kilowatt on this chart, is around $721 a year, or $60 a month. And this is actual data that is monitored. So in Michigan, I have over 400 systems installed. And again, our average cost for heating and cooling year round, $805, or $67 a month. So we have a 7 series unit. It's also inverter driven variable speed compressor. And that also has 10 different speeds and adjusts itself like a cruise control would. And again, saves a great deal of electricity. Even on startup, it only has 10 amps on startup compared to a standard compressor of about 100 amps on startup, black rotor amps. So they're showing here that the usage on this unit, 7 series 4-ton, produces 3920 kilowatt hours, or approximately $490 a year, or $41 a month. And then a 5-ton unit, you show a little bit higher usage, 6983 kilowatt hours, or $873, or a year, $73 a month. And that is actual data that we acquire. So utilities, and going to thermal grids, we can base load 15% of their home and save them that much. It also provides the net present value form, the best present value. Our loops in the ground can last over 100 years. So our units last probably around, they estimate 25 years from AHRI data. So you can reuse that loop and gain energy and less cost for further advancement and replacements. So we're estimating the paybacks on most applications are around 7 years over a fossil fuel appliance, and less, of course, if it's a propane or oil based appliance. So providing the ground loop is probably pretty much more cost effective than running gas lines over 200 feet from the main gas supply in a residential neighborhood or a country urban setting. And I'm going to hand this off now and talk about the heat pump water heaters.
Thank you, Al. Appreciate that.
Thanks.
Oh, hold on. Here we go. Lost me. Okay. Well, good afternoon, everyone. Sorry, I lost the screen here. So let's go up to this. Okay. Can everyone see that?
Yep.
Great. Okay. No, you don't want that. Hold on.
Oh yeah, just you want to hit play on it.
Okay, gotcha. All right. So my name is Tim Goggin with Rheem Water Heating, regional sales manager for the Midwest, Great Lakes, and other states included. I don't know if many of you know about heat pump water heaters or much about Rheem, but we're a global manufacturer with a significant footprint in the North America in all channels. And heat pump water heating has become very relevant in the last several years, especially with everyone concerned about the environment as well as saving energy. And thank you for inviting me today to speak about it. Why care about heat pump water heating? It's the second highest energy user in the home. Okay, now as a manufacturer of the products we make represents 65%, so it's very relevant in regards to saving energy. It's the most efficient way to heat water. It moves heat from one place to another, okay, instead of generating heat directly. The old-fashioned, which are very prominent today, are the resistor element heaters, which are great, right? But they need energy to create heat. Heat pump water heaters draw heat from its current environment, okay, and utilize that heat to generate water, hot water. It's the only appliance that provides actually technology over 100% efficient. Actually, they're 300% efficient. They use very little energy, and the payback is significant. And ultimately, in the heat pump mode, it saves $480 per year, okay, for the average consumer. Now, how does it work? Okay, the fan draws ambient heat over the evaporator coil. The evaporator coil then absorbs the heat, okay, and the compressor increases the pressure and temperature of the refrigerant. It's kind of like a refrigerator in reverse. It captures that heat, and that heat then can get up to 160 degrees, okay? The heated refrigerant then is wrapped around the outside tank, not the inside, it's the outside. And the temperature then permeates in through the tank into the water itself. Now, this is a real eye opener when it comes to what your return on investment is, okay? And this is compared a 50 gallon at 30 amps hybrid heat pump water heater versus a standard tall 50 gallon electric, okay? These are estimates and these are averages that I'm sharing with you. So this could deviate from based on kilowatt hours and things that typically are charged. You can expect on a 50 to pay somewhere between $1,200 to $1,300 without any incentives out there that are offered by utilities. But I encourage you to look to see what incentives may be out there from your local utilities. The initial investment for a standard electric water heater, which is relevant to your market, is around $400, $420. What is the most important part, though, is what your annual operating costs are. A hybrid heat pump water heater, roughly $130, okay, and that's in a heat pump mode. You also have the electric mode, and again, you're looking at $530, so you're looking at it in significant savings over a 10-year period of time. And it does have a 10-year warranty, and that's what the numbers are based on. So if you're saving $400 a year over a 10-year period of time, you're roughly saving just under $4,000 to the homeowner. So if you look at your initial investment, it literally pays for itself in just under 3 months, okay? And the one thing I also want to bring to your attention is that it also qualifies for a federal tax incentive of $300, which helps offset some of the initial cost of the unit itself. So from a builder's perspective, it's smart. Smart features built in, space-saving design. This has a zero clearance requirement, other than you need 6 to 8 inches on the very top of the water heater to get the media filter out for cleaning. Okay, so it does maximize living space. Again, utility rooms don't have to be that big, especially with 90+ furnaces that are typically used. It's sustainable, okay? It's designed to maximize HERS and EDR scores. And those that aren't familiar with it, HERS scores is the overall energy envelope of the home, and the hybrid heat pump water heaters, specifically the Proterra, improve that number anywhere from 4 to 7 points, which is significant. And savings, again, $480 savings per year on average. And there are other features built within this model that actually can improve that on a yearly basis. And that is tied more to utility replication of what energy ratings are and things of that nature. So without further ado, I'd like to pass along to Mr. Bill Myers with Panasonic. And thank you everyone for having me today.
Thanks, Tim. So, like you said, my name is Bill Myers. I am the regional construction sales representative for Panasonic ventilation in the Upper Midwest territory. And today we're going to talk about whole home ventilation and how that works in conjunction with our energy efficient homes. So, we've become experts at sealing on the outside world. If you look at a home today as opposed to a home that was built 50 years ago, construction's changed. The biggest thing on our side of it is since the 1960s, we've increased the efficiency of sealing up our homes 320% on average. So we've made our homes safer, correct? We'd like to believe that, but according to the EPA and the American Lung Association, homes are a leading contributor to sickness, or being in the home is a leading contributor to sickness nowadays because the ventilation is just poor in these homes. Some of the stats that jump out to me is 90% of all colds, flus are caught indoors. We haven't gotten the numbers back from studies, but I'd like to think that the COVID virus is going to be in that same type of percentage range. Another thing that really jumps out is 72% rate. Pediatric asthma rates have jumped 72% in the last few years because homes are just so tightly insulated and so tightly bound that the fresh air is making these kids, or the lack of fresh air is making these kids sicker. And now that kids are staying in to do online schooling, more kids are staying in to play video games, watch TVs, play on computers. Kids don't get out and get fresh air that they used to. So we need to get the home to breathe so that the kids stay healthy. And the last one that really jumps out to me is a study was done on women who work from home, and 54% of women that work from home are more likely to develop cancer and die from it than women that work out in outside of the home. So, all of these factors contribute to poor indoor air quality as being ranked as the #4 biggest environmental threat in the United States currently. So how do we fix that? Well, we have to go with a proper ventilation strategy in the home to offset that. With proper ventilation, we can neutralize or decrease the rate of airborne viruses like flu, like SARS. And numerous studies show that the more air changes we get, or the more fresh air we get into the home, it will decrease the infection rate of airborne diseases. The other thing is it will keep the humidity in the home in that mid-range between 40 and 60%. And that is the sweet spot where airborne pathogens and viruses, they don't thrive between that 40 and 60% relative humidity. So proper ventilation can help that number and help keep that home in that sweet spot. So what we need to do is we need to build a better IAQ strategy. We need to build a strategy based on demand ventilation and not use a one-size-fits-all approach that we've used in the past. We need to address ventilation, based on square footage and occupancy, and not on assumptions on, what the flow rate should be, or the proper amount of CFM that are flowing into that home. We also need to base our ventilation strategy on real world factors, such as your climate zone, the occupational or the habits of the occupants that live inside that home, and how tight is that home that the occupants are living in. So what's the best solution to proper indoor air quality? Many experts feel that a proper that an ERV, or energy recovery ventilator, is going to be the best way to properly ventilate a house. And for those that don't understand, an ERV is basically an air exchanger. It will bring in fresh air from outdoors and exhaust out stale air from indoors. And what this will do is, say in a climate where it's cold, you'll get better control of the air exchanges between the indoor and outdoor. But as that cold air is coming in, it's going to temper it with your warm conditioned air that's going out, and your heat pump, your Mitsubishi heat pump is going to have to work less so that it can bring the air temperature to where it needs to be. The other big thing about it is where the fresh air comes from is now from a known source. In the past, it was through infiltration. So you'd be getting your fresh air from leaks, from cracks, could be through the floorboards, could be through the windows. You didn't know where fresh air was coming from. Now you'll have that fresh air placed in an area, say on the backside of the house, away from the roadway or away from where the garbage collection site is, so that you know that the freshest air that you can get is coming into the home. It's going through a filtered system, and then it's actually getting tempered and put into the house. Like I say, benefits of the ERV. The ERV will recover both latent and sensible heat. So it will recover actual temperature, and it will recover relative humidity and pass that through, so that the house will get what it needs. Excess moisture can be reduced in a humid climate, but in a dry climate, it can retain moisture. So it's a perfect mix for that air exchange. Here's a quick slide that kind of helps you understand the efficiencies of an ERV. By this slide, if you're looking at it, the outside air temperature, a typical summer day in this is 104 degrees. Your conditioned air that's inside the home is 71 degrees. Those two air streams will cross through the core of the ERV, and the air actually never touches to cross-contaminate, but it will cross in the core, and the inside air will temper the outside air. So the air that actually gets forced through and dropped into the home then goes from that 104 degrees and now becomes 75 degrees. And if you run the numbers, that is a 72% efficient transfer of heat. So that 104, now it's 75. Now to get your HVAC system to adjust that 75 degrees down to 71 is far easier on it, and and provides more energy savings. This slide is a quick comparison of brands of ERVs that are out there. We do have the Panasonic, but you also have Zehnder, Vinmar, Aldi's, Fantech, other brands that do the job and do the job well. Like I say, this is a quick slide that shows the 100 to 150 CFM category. And if you look, what really stands out is the efficiency numbers on there. Most of these units are anywhere from that 64, ARI rated at 64%, and drops down to about 50%. Once you talk the Panasonic difference, the Panasonic ERV has dual ECM motors for supply and return air. You can set those motors independent of each other in 10 CFM increments from 50 to 100 CFM. So you can dial in by square footage of the home and by amount of occupants in the home. The Panasonic does have a boost function. So if the occupants are having a party, they could walk over, they could flip a wall switch. That ERV will boost up to full supply or full run on the supply side, and it'll get that fresh air, more fresh air into the home to help offset all the stale air that's being generated because of the party. There is a cold air version that will put the unit into defrost when need be for the Michigan area. So you won't have any issues, with frosting coil and with airflow, improper airflow. And finally, what's in the future for Panasonic? A couple articles here from This Old House and from Panasonic Sheet. Panasonic is working on a whole home IAQ system now, which basically will have a monitoring system that will be able to tell you what's going on in the home with either VOCs, with temperature, with humidity. And now that monitor will communicate wirelessly with the fans, and they can either turn on fans, turn off fans, ramp them up, ramp them down, give you what you need so that the home is always at that perfect sweet spot that you set it at. So that now you're not doing just exhaust only, or you're not worrying about, opening windows or, what have you. The system will work independently and provide you that fresh air that you need to keep the house healthy. And with that, I will hand this off to Rob Morosky with ICF. Thank you for your time.
Good afternoon, everybody. Just here to talk to you guys a little bit about the home energy rating system. Just a brief description of what it is. It's used as a metric not only for code compliance in over 15 states, but as an Energy Star benchmark as well. Home buyers, realtors, appraisers, and utilities use the HERS rating system for home comparisons. A HERS index of 100 is representative to a home built to 2006 energy efficiency standard. Every 1 point change represents a 1% change in energy use. Home with a HERS index of 0 produces as much energy on site as it uses. To date, excuse me, over 2 million HERS rated homes nationally since its inception. In 2018, there were 3,166 HERS rated homes in Michigan with an average score of 57. In 2019, that rose to 3,665 with an average score of 58. HERS raters are highly trained professionals that adhere to strict quality assurance protocols. I know we have a couple of you guys on the call today. We also report to ResNet certified rating providers for quality assurance, oversight on files, and field inspections. We're a trusted third-party energy code inspectors plus more. We're experienced in conducting energy efficient plan reviews to determine savings measures, building envelope leakage testing. So we're testing how tight these houses are actually being built. We're testing how tight the ductwork is throughout the house. And we also do pre-drywall inspections for air sealing and insulation deficiencies. We're recognized by the EPA, the Department of Energy, the U.S. mortgage industry, and the ICC. We have a number of different trade-offs for lowering HERS scores. Just listed a couple here, and we've already talked about a couple in the presentation already. Rater, basically number one, quality insulation installation. We can grade installation quality at 1, 2, or 3 based on the number of gaps in compression. A grade 1 could mean a couple points versus a grade 3. Reducing the amount of infiltration throughout the building leads to more savings and greater comfort levels. Balance controlled ventilations, an ERV like we were just talking about, or energy recovery ventilator exchanges the energy contained in normally exhausted air, using it to pre-treat and condition incoming fresh air. It definitely improves indoor air quality and reduces overall loads on HVAC systems, definitely bringing HERS scores down. And heat pump water heaters can offer, compared to a typical electric water heater, up to 4 times the efficiency. We see a lot of gas water heaters out here in the field. Couple slides on what type of equipment we see here in Michigan, and the HERS scores that equipment essentially represents. So getting lower HERS scores, you can see right there, heat pump, there's definitely a value there to lowering HERS scores. And when these pilot programs are coming out, The lower the HERS score, the higher the incentives for the builders. When we use the gas, the fuel-fired distribution systems that we see a lot of, the HERS scores definitely increase dramatically there. Ventilation types, we really see, I've seen a lot of the air handler supply only type strategies out there, but we're starting to see a little bit more exhaust ventilation. But again, if you look at that balanced type ventilation with an ERV or HRV, we're seeing much lower HERS scores as a general rule. And same with water heater types. You know, the HERS score less than 26, we see about 30% of those have heat pump water heaters. About 35% are still conventional gas. And we're starting to see a few more instant water heaters out there as well. But when we look at the 26 to 48 grouping, definitely more gas water heaters that are involved in those higher scores. Typically, again, one of our big things that we see out there is the HERS score that's above 26, definitely, and they're typically natural gas and propane water heaters that are getting those higher numbers. And again, we see the electric water heaters, they definitely are increasing or lowering those HERS scores, increasing efficiency throughout the system. With that, we're going to pass it off to Jenny again.
Thanks, Rob. All right, so I'm Jenny. I'm with ICF, and ICF actually implements the DTE Energy and Consumers Energy new home construction programs. Yep, thanks for the slide. And including the all-electric pilots that have been launched and will be launching soon for consumers. All right, so I get to talk about the fun part, the incentives that we're able to offer builders for making these awesome energy efficient upgrades and going all electric. So I'm excited to announce that DTE has actually already launched a pilot for all electric new home construction earlier this year, and we're still accepting applications for new builders who are building all electric homes in DTE's electric service territory. So this pilot takes into account various aspects of the home. You can see this little diagram here. It's looking at the insulation, the HVAC, the water heating, lighting, appliances, all of that. And these pilots are both running, both DTE and Consumers Energy are running through November of 2021, meaning that the home needs to be completed by then and receive their final HERS rating. These incentives are paid directly to the builders, and both for DTE and Consumers Energy, we have a few requirements. So the builder is required to work with a home energy rater to develop plans for their house and have that home modeled. And then they're required to submit a builder application, which you can actually see I attached the, there's a market rate application and a affordable housing application attached in the handout section of this webinar on your panel. So builders are required to work with home energy raters and have a heat pump as their primary heating equipment. That can be either the geothermal equipment or the air source heat pump that were touched on in this webinar. And also they must meet a specific HERS score. Rob was just touching on the HERS score and how that works. And I'll get a little bit more into the details on what exact scores are required. As I mentioned, DTE launched the pilot already, and we're currently accepting applications. We are requiring that a home energy score of 40 or less is met, and your home energy rater can help you determine the score and make suggestions, tell you where you can improve on these homes and how to get your score to 40. And then also, if you go the extra mile to get down to HERS 35, we're offering bonuses. So definitely something to look out for. On the right side of the screen, you can see some of the measures that we're incentivizing. So it's not just the home has to be all electric, as simple as that. We want to make sure this is a good home and the clients are the customers and homeowners are comfortable in the home. So you see here we have a few different options listed, and the exact incentive detail is actually provided in our application. But I do have over here the caps that are listed. So an affordable house can receive an incentive of up to $20,000, and then a market rate home can receive an incentive of up to $9,200. And when you take a look at the application, you'll be able to see how you get up to that incentive and fully utilize it. And then alternatively, if you're building high efficiency homes but all electric, you don't quite meet the requirements of this regarding the HERS score, or just building high efficiency homes, we do still have a DTENewHome construction program that we have information about.
Hi, my name is Ross Igo, and I am with ICF, and I am currently helping and working with the Consumers Energy Pilots team to help develop and implement the new home electrification pilot for market rate and affordable home builders. So over the course of the past 6 months, we have been completing outreach and market research to gain input and perspectives from Michigan home builders across Consumers Energy territory, as we are expecting to launch this pilot here upcoming in January of 2021. So similar to the DTE program, we will have participation agreements available for both market rate home builders and affordable home builders constructing home in Consumers Energy electric and dual fuel territories. So we don't have a defined incentive structure yet, but incentives will be available for all electric homes achieving a HERS score of 40 or less, with possible bonuses for homes that achieve a HERS score of 35 or less, and a HERS score of 20 or less, indicating that there was some type of on-site generation at the home. So any home that does not meet program requirements, like the DTE program, can still go through the traditional standard Consumers Energy new home construction program. So there's always that option as well. And finally, as you can see from the timeline below, we will be finalizing our program design, incentives, and agreement forms in Q4 of 2020 or Q4 of this year. So I am excited to begin reaching out to interested builders and begin accepting some of those applications as we get ready for the 2021 kickoff. So I'll be in touch throughout the rest of the year for anybody interested. And that's all I have. Thank you.
All right. Well, it looks like we've got a lot of questions, a lot of chatter going on, and we got time to get to a lot of those questions. So let's try to get through them. One of them that I just want to, that was just kind of fresh on the top of my mind, Ross, because you had just said a term here. You said on-site generation. So if I want to understand right, which, typically that's another term for solar energy, because that's usually what we have, all we have available right now. So are you saying you have incentives for solar, or you may require solar? And then is that going to be for DTE too, or just consumers, or did I hear that right?
So incentives wouldn't be directly required for solar. That's why we're having that bonus available for HERS 20 or less. We have found through the first phase of the pilot that with some on-site generation, we're seeing HERS scores of about around the 15 range. So with that being a possible bonus, that's what we're looking for. So a bonus that would indicate on-site generation for solar, not necessarily a incentive directly tied to having PV generation.
Okay. And so does that still require then a 35 on the HERS index pre-generation?
Yes. So before on-site generation, you'd have to achieve a HERS score of 40 or less to qualify for the program. And if not, then you'd still be able to go through the standard new construction program if the HERS score was above 40 prior to generation.
Got it. Jennifer, I don't know if you had anything to add on that from the DTE side or not.
Yeah, I just wanted to also say that DTE is requiring the HERS score of a 40 or less before PV. So.
And then another real quick thing, Ross, was do you have a low income variation that you're planning that's going to be similar to DTE's in some way?
Yes, that's in the works as well. So as I said, we are finalizing those participation agreements here this month, and hopefully have those ready by the end of November, so we can get them out in December. But we would have two variations: one for the market rate program and one for the affordable income eligible builders out there. So only real differences would be, as you saw in the DTE, the income eligible builders would be qualify for higher incentives, but will be fairly in line with what you saw on Jenny's slides for the DTE program.
Great. Well, let's dive into some of the technology questions. I mean, obviously it takes some different technology to get to achieve these goals. And there's been a lot of technical questions coming in, a lot of great conversation here. One of them for you, Greg, are the MXZ units VRF?
No, so technically they're not a VRF. VRF is really used more in the commercial side. We're not really changing the flow of refrigerant. We're slowing the compressor down, changing the temperature in the refrigerant. In multi-zones, we're really using the other heads as kind of like an accumulator, so it still pushes that refrigerant down those other zones. And that's why we use things like thermal fan off and temperature changes in the coil adjustments for those systems. And that's done because of cost related in terms of putting these systems in residential applications. To do a full variable refrigerant flow type system can get very costly.
Great, thank you, Greg. Looking at ground source heat pump systems, Al, there was a sort of comment, I don't know if it was a question, but more of a comment, but maybe you can speak to it. They were saying your systems have something in place to be monitored for 1 year, but they said they think they noticed other geothermal systems don't have that monitoring or don't require it. I'm not too sure what they're getting at with this question, but maybe it's ringing a bell for you.
Well, the system is it's similar to a Wi-Fi thermostat, but we're actually connecting to the unit itself and monitoring our water inlet and outlet, our air inlet, outlet across the coil. We're actually keeping track of the heat of extraction from the loop and the ground and heat of rejection in the summertime. As we pull the heat from the house, we're able to dispense and have that thermal exchange with the earth. So really, the Symphony Wi-Fi program is an addition. It's an option that you can buy with our unit, and you have to buy the advanced controls in order to get the refrigerant monitoring and the air monitoring type of controlling and monitoring. But what it really does is provide good data and true data of the energy savings and the amount of energy that we're actually using to heat and cool a home. And we also have a program called the GeoLink program that our contractors can use beforehand and enter the data, the BTU capacity of the home, the heat loss, the heat gain. They can size the loop properly to make sure we have the right size of the loop in the ground to exchange the heat properly and the BTUs that are needed. And now that data, even before it's installed, putting in the numbers in your electric cost or gas cost will give you a good annual projection of what the savings would be over one of the fuels or the other. And we find out that data is very efficient and right on the money compared to our Symphony Wi-Fi after it's been running over a year. We're within 1% of that data. So we've come a long way of projecting and sizing and calculating the BTUs available in the earth. Even when it's 0 degrees outside, that earth temperature still 30 to 50 degrees, depending on how deep or what type of medium we're using to transfer the heat.
Great, thank you, Al. There's a lot of conversation going on here, some questions on the heat pump water heaters, air source heat pump water heaters. Tim, I don't know if you took off out there, but Mike, I see that you're on, so hopefully you can help us out if you can hear us. Just somebody mentioning a comment that, they installed one of these things and, the area around it is now pretty cold. So if you can speak to that a little bit, and then there was some questions about the fact that you could do ducting with these things, maybe to solve that issue.
Certainly. I think Tim had to duck off the call. If not, I can't see if he's still on, but happy to answer that. Traditionally, yes, the ambient air used in that space obviously will see some temperature decrease in the basement or in that mechanical room. We do have units that will allow you to vent to the outside, thus keeping the air temperature at a more comfortable rate. So yes, we do offer that.
Great. And then the next question was, there's these new heat pump water heaters coming on the market. They're split systems. They've got the outdoor condenser unit, maybe running some different types of refrigerants. What are you seeing with that out there? Is that something Rheem's looking into?
That I couldn't speak directly to, being a representative of Rheem, not a direct employee. That would be something that Tim would probably have to acknowledge or have some input maybe in the future. If somebody wanted to email him, I think that'd be a great question to ask.
Yeah, and Tim and everybody's contact information is up on the slide, and it was shared out with everybody in the downloaded handouts. If you haven't seen the handouts, there's a link. You can access all the handouts to look at all of the DTE rebates for both income qualified, market rate, and just the general consumer brochure. So let's talk renovations, existing homes. Jennifer, maybe we'll start with you. And if it's the same thing for consumers, let us know. But what can we do with those kinds of homes in a program like this, or can they not be involved?
Yeah, thank you for that question. And sorry I didn't touch on this, but yes, the DTE pilot is accepting single-family homes, townhomes, and also full gut rehabs. So the full gut rehab needs to be built to the 2015 Michigan Energy Code, the most recent code, and truly be a full gut rehab. If it is not a full gut rehab, DTE does have other opportunities, rebate programs where they can participate, potentially just for like replacing the HVAC equipment or insulation. Check out dteenergy.com/save-energy.
And for the consumers program, we are still finalizing those program requirements, but as of right now, I am forecasting that we would have the same requirements for single family, duplex and townhomes, and then a full gut rehab to the 2015 IECC.
What if somebody we've seen existing homes that don't do guts achieve those HERS levels. Is there any conversation to be had there, or is it that you have to get to the 2015 IECC levels in the thermal envelope, which I know can be difficult without gutting it?
Yeah, nothing right now. Currently, yeah, it's just a full gut rehab, getting to that HERS score to participate in the pilot.
Great. Well, I see one more question here. I know we're about 1 minute to the hour. I just wanted to real quick remind everybody we've got a big, we're going to keep this conversation going on how do we do this with our homes in Michigan. We've got our big residential net zero energy conference happening. It's free to register. I'm going to throw the link into the chat there. It's going to be next week during the evening, Tuesday, Wednesday, and Thursday, and we're going to keep this conversation going. So I hope all of you can join us or spread the word on that as well. And then I'm also throwing in that HERS data study that was referenced earlier on some of the all-electric homes. So this other question that came in real quick is, I know DTE has a special rate for those who are on ground source heat pump systems, a special electric rate, if I understand right. And I know, Al, your team worked a lot to make that happen. Do we see that happening for consumers or DTE for air source heat pump systems, whether it be water or space heating? Is there any conversation that anyone knows, knows about going on there?
For consumers, as a representative, I'm not probably the one that answered that question, but if you would like to email me that, I could reach out and get that answered for you.
Currently, DTE offers a separate meter discount rate for the geothermal heat pump, and also the Michigan Co-op Electric Association, and those co-ops do the same. And reason being, again, it helps them reduce their peak energy demand in the summer months, where they really need to reduce that high demand. And then in the winter months, as there's a big valley of electric use and there's plenty available, it helps them as a utility company maintain good value and sales in their electric production.
Great,
Yeah,
thanks. Oh,
Brent,
go ahead.
I touched upon that. That was the interruptible service that I mentioned in that rate that I showed you. We have done it on a couple of DTE pilot installations, and that's how they utilize that through the interruptible. So it's similar they can only interrupt during the cooling season. They can't interrupt during the heating season, but they can give you a better rate by having that second meter.
Oh, so it's, if I understand correctly, it's when they can basically throttle back your system during intense usage. Is that, I guess?
Correct.
Okay.
Correct. During the cooling season only, right? But they
Okay.
offer the lower rate throughout the year by having that second meter.
Okay. And so I know Consumers has a similar program. Have you worked with them at all? Yeah.
Correct.
Okay. Okay. Now it all makes sense. So, well, I do not see any other questions here. Everybody's contact information is on the slide. It's in the handout. But for the sake of the rebate pilot, which is what the focus of this conversation was, Jennifer, just real quick, where can people reach out to contact you to learn more, to get started?
Yes, feel free to contact me directly here. I have my email address, jennifer.abraham@icf.com, and I can give you all the information that is needed.
And Ross?
Same. Please feel free to reach out through my email listed below, ross.igoe, IGOE @icf.com. And I'd be happy to keep you in the loop. We have a contact list right now currently with interested builders, so can keep you up to date with any news and developments as we continue to finalize our program design and incentive structure here in Q4 of this year.
All right. Well, Jennifer, thank you so much for organizing this whole thing and getting us all together. This has been a great conversation. We're all excited to help see the residential market move forward with high performance homes in the state. So have a great rest of your week. Stay safe out there, everyone. Take care. Thank you.
Thank you.